Assalamu alaikum, girls.
Walaikum assalam. Miss.
Good morning. How are you all?
Fine, Miss.
Okay. So let's start our class today. If you remember, yesterday we have finished about the circuit, whether it is a parallel circuit, series circuit, and how to design the circuit of electricity in your flat. We discussed about it, right, girls?
Yes.
I hope you have gone through all the notes. Did you find any difficulty over there?
No.
Okay, that's very good. So today I want to proceed this one. We'll go to our next topic, that is mains plug. Means the plug that from our appliances or our device, the one we put in the socket and it is connected to the electricity. And the particular device starts functioning. We call that one as the mains plug. Now, generally, as all of us are using different electrical appliances at home, so we can understand that we have, or we know that we have two type of plug at home. Some of them are 3-pin, we call it, which has 3 pins. You have to put it in a 3-pin socket, then it is getting connected. As well as we have another one that is called 2-pin socket, 2-pin plug, we call it. Now, I want to ask you a question. As you are big enough, and sometimes I think at home you are switching on your different devices or plugging it in as well. Did you notice that in 3-pin socket, there are 3 holes, right? Sometimes when you use the 2-pin plug in the 3-pin socket, the particular device starts functioning. Did you notice that, girls? Did you understand my question?
Yes.
Okay, I want to repeat the question. All of you listen to me. That is the 3-pin socket, the one which is on the wall or up in a board. And you have an appliance which is having a 2-pin plug. Even if you place that 2-pin on the 3-pin socket, it still functions. Did you notice it?
Yes, ma'am. Yes.
Yes, that is true. It does work. And why it is working and why that 2-pin is important, and the third one sometimes we can even omit. We'll discuss all about it. So I want to start with the mains plug. We'll be discussing first of all the 3-pin plug, the one which is having 3 pins. Okay, first, if you just understand it, that mains electricity is alternating current. Okay, before that I told you that the cell and the battery that is providing the electricity to us is actually nothing but DC. But the electrical power supply, the one we are using at home, that is AC, because it is coming from the electrical power station. And it has a behavior that it is nothing but an alternating current. And alternating current is having a behavior that it keeps on changing its direction. 2 times it changes its direction in one cycle. That is why we say that, and what is a cycle? It is the frequency, we say, number of waves completed in 1 second. That is called the cycle. How many cycle will be there? That many means 2 times of that number will be the change of direction of the electricity. So we wrote it initially that it flows backwards and forwards 50 to 60 times per second. Yes, girls. Okay, let me continue. I was telling you, think about if I say the electricity that we are using at home is having a frequency of 25 hertz or 30 hertz. It means that it is going to change its direction of electricity 30 multiplied by 2, that is 60 times. That is why I mentioned over here, it can be 50 or it can be 60 times is going to change the direction. All through the journey, as long as it is coming to our main board, from where we're going to connect it and get the electricity. Okay, and now let us come to the point that if it is a 3-pin plug, then how many plugs we are having, and these plugs means how many pins we are having, and these pins are connected to which wire. They have different names of this wire. First, we'll discuss about live wire, which is the most important among the 3 pins. Of the 3 pins that we have, the first one is the live wire. Actually, this is the one which is connecting our device to the electrical circuit. So we say this goes alternately negative and positive, making the current flow backwards and forwards through the circuit. It is brown in color and a fuse is connected in the live wire. This is very important point, girls. You'll remember. We have to remember the color because you might have seen till now that color actually plays a very vital role in this electricity. We have seen that we have two colors, that's black and red, for two identifying two terminals, positive terminal, negative terminal. Now we came to know that in a 3-pin plug there will be a wire. Means actually we have all these plugs in school. I have with me. So once the school is opening, then I can show you all of it. We'll open the 3-pin plug and we'll see there are 3 wires connected. One of them will be brown in color. That is the one which one we call live wire. And this live wire actually connects our appliances to the mains electricity. Okay. Now, second point is that neutral wire we call it. As we know that once it is connected, it has to complete the circuit. So you can say neutral wire is the one which actually completes the circuit. This completes the circuit and it is blue in color. We have to remember that live wire is brown and neutral wire is blue. So if I have a live wire and a neutral wire, my circuit is completed and my appliances or device will start functioning. That is why initially I asked you that is it possible with a 2-pin plug I will be placing in a 3-pin socket, but still my appliance will function. This is the main point. Means we need to have a live wire to start the circuit and a neutral wire to complete the circuit, so that our appliances will start working. Is it clear, girls? Okay. Now let's go to the other one, the one which is actually giving us or protecting our appliances from getting damaged. That is called earth wire, the third one. So it is a safety wire actually, and it is actually looks like green and yellow stripe. It is green and yellow striped in color. So you remember the colors very nicely. The first one is blue in color, brown in color, that is a live wire. Neutral wire is blue in color. Earth wire will be green and yellow striped in color. If the live wire comes loose, because you know there can be anytime a loose connection. If the live wire comes loose and current passes immediately to the earth wire and blows the fuse. What is the fuse? The fuse is connected in the live wire. You see, I have given the diagram afterwards. You'll always remember from the live wire, it has to go through a fuse. And what is a fuse? I'll tell you afterwards. In this particular part, we have it. In that fuse, the electricity will go and then it will go to the appliances, so that your appliances will be safe during any accident, means overcurrent or over voltage. Any electrical accident, it can keep your appliances get from, or it actually helps your appliances from not getting damaged, because over electricity can anytime damage the particular device. Its circuit will be burned away and it will not be functioning anymore. Okay. So now just tell me, do you have any doubt regarding these 3 pins in the mains plug?
No, miss.
Okay, very good. So first of all, here are a few points you have to remember. That is, first thing you have to remember is, that is the colors of the wires, and which 2 wires are very important to us. Number 1, that is the live wire, as I told you, it is brown in color, and it is the one which actually connects our appliances to the main circuit. Point number 2, neutral wire, because it is going to complete the circuit. It is blue in color and the device will start functioning. And the third one, earth wire, actually keeps the appliances being safe from the electricity, over electricity or any electrical accident. Okay. Now, let's go to the next point, that is dangers of electricity. If you remember, in static electricity, we discussed some of the dangers caused by the static electricity. Now, this is all about the current electricity, and in our everyday life, we are using electricity in every purpose. So many purposes we are using. So we need to be very careful regarding some of the points, so that we can protect ourselves from any type of accident, electrical accident that can happen to us. Okay, I wrote some of the points. You check it. You'll be getting lots of questions from here. And sometimes, you know, only from this point, they give you one 5-mark question, full 5-mark question. So these points are really important to remember. The first one is that we say mains electricity can be dangerous due to its high voltage. Now, before I told you that the small cell, the one which can provide us this electricity, we are using, that is having a voltage of only around 1.5 volt, the smallest voltage that we can get from a small cell. Okay, but think about the electricity that we are using at home. It has 220 volt, a huge amount of electricity that can anytime with any electrical accident can kill a person. So it's really dangerous, as well as we have to work with it. So we need to know some of the points that can actually help us to protect from any electrical accident. What are those? Okay, let me remind you. In case we do have another line also in our home line. I don't know, some of your students might be having at home two lines, like I have in my home, 220 and 110. Two electrical lines are there. But there is another line, the one we call 440 volt, which is really high, that mostly is given to the industries, industrial purposes, or the industries which are producing so many goods, items, and all. They need a very high voltage to run a huge amount of machineries, or high voltage electrical appliances they need to use. So they use 440. Our home lamp is 220 volt, and we're going to discuss about the dangers that can happen due to this 220 volt. Point number one, I wrote damaged insulation. Now, what is this insulation and why we need to discuss about it? First of all, if you just look at any electrical wire, you will see on the top there is a plastic coating. Okay, we call it as nothing but an insulation, and we know that plastic is one of the best possible insulation we can find. So, and what is this wire? These are all made up of copper. We know copper is a very good conductor, which allows the electricity to pass through very easily. Less amount of resistance is also there. At the same time, you have to remember, resistance depends on two things: the length of the wire as well as the cross section of area. So let us come back to this point that we discuss about any electrical wire which is actually allowing the electricity to pass through, and we need to have a coating on the top. So this coating is nothing but the insulation provided by the industry, those who are making it. So due to any reason, if there is any damage on this, the wires are getting exposed to us. Just imagine you're working with appliances. Somewhere there's a part where this insulation came off and the copper wire is exposed. So it can be happening that anytime you can touch that particular part and you get exposed to that high voltage electricity. That can be a huge shock, as well as it can cause a person to die, the one we call electrocution. Right? So this is one dangerous point, that is damaged insulation. We have to ensure when we are using the appliances that they are not having any type of damaged insulation. Even if it is damaged, we can do something. I want to ask you girls, do you have any practical knowledge what you can do to use that particular wire but without any risk? Can we do something about it?
We can wear gloves, right?
But I don't want to wear the gloves. I want to do something to the wire. So what can be the suggestion?
Wrap with the gauze tape or tape.
Uh, I don't want to use the word scotch tape. We can say insulating tape. You will see some black, yellow, blue colored tape. We are using at home all the time for these electrical purposes. With that, you can wrap that part where it has the damaged insulation. So for the time being, you can use it. Okay, before replacing the wire with a new one, for the time being, we can use it. At least you will be safe from getting any electric shock. Okay, fine. Next point, I wrote old frayed wires. Now, this particular thing you have to remember that whenever we use a wire for a long time, there is always a chance that it can be old as well as it can be frayed. Now, what is this frayed word? It shows that, now I'll tell you one thing else. Did you ever open any electrical wire and check how many wires or how the wires are there inside? Did you ever check it? Anyone?
Yes.
Okay, so is there a single wire there or there are a number of wires there?
Two wires?
Three, four wires, yeah. It depends on the particular purpose. There is actually few numbers of wires all together. You put a insulation on the top and together it becomes a single wire. And we do have a reason behind it also, that why we have to put 3, 4 wires. So it happens like that because from the outside you cannot see anything. So when we're scratching it and it is working for a long time, there is every chance that somewhere in one of the wire or two of the wire can be broken down in the middle. So when it is broken down, so don't you think that particular part, think about I have all through the wire, 4 wires inside. So 2 of them got broken down, and that after breaking that wire, or don't you think those 2 wires will move a little bit far from each other to two broken sides? And in the middle only there will be 2 wires. The 2 wires that is left there among the 4. So that particular part, don't you think it is getting thinner than the rest of the wire? What do you say, guys? Is it clear to you what I am trying to say? You have 4 wires all together, 4 thin metal wires together, and on the top the coating is given, means the insulation is given, so it becomes all through a single wire. For long use or for any type of accident, or sometimes we stretch it, due to that, 2 of the wires inside, somewhere in a particular part, it got broken down. So after got broken down, they will move away from each other. Then that particular part where it got broken down will become thinner than the rest of the part. Am I right, girls?
Yeah.
Okay, fine. So then what happens? That particular part becomes thinner. Thinner means what? We know that thinner wires do have very high resistance. So when electricity comes to that particular part, it becomes very hot, means the temperature goes really high, and there can be a chance it melts, or it can even catch fire, which can cause a huge amount of damage to the particular appliances, or it might make the house on fire. So we need to be very careful when we are using an appliance for a long time. We have to be careful about the wires that is connected to the main circuit. If it is old, we can just take it off, replace and use it again, put another new one and start using the appliances one more time. Okay, now the next point, it is a bit similar to point number 2, overheating of cables. Okay, now I will ask you one thing. Sometimes girls, even right now as I am using my laptop, I have one extension board, means the one which is coming from the main supply, and I have an extension. There are 3, 4 pins are there, and I'm placing my laptop in one, and another one I place my mobile, which is heating, which is charging. So this type of boards we call extension plug. And you know that this extension plugs do have a long wire which is connected to the mains. So sometimes what we do for making it neat, we just roll down the extra wires together and put it on together, means we tie it with a rubber band or something and put it together. We do it like this sometimes, but it's a very, very wrong thing to do. Why? I'll tell you. When it is coiled up, that means what happens? Whenever electricity passes through any appliances or any wire or any metals, it creates a heating effect. So this heat has to go to the surroundings. Otherwise, it gets trapped and the temperature goes even higher than that. That time there's a chance this insulation will get melted, and then there can be a fire as well. So we call it overheating that can cause fire. Is it clear, girls? So when we are using an extension plug, we have to ensure that we are keeping the wire open and to allow more surface area to release the thermal energy to the surroundings, so that the heat should not get trapped within the wires. Then there will be overheating, and of course the wire will melt, and that will also melt the insulation and cause a fire. So this is also equally dangerous to us when we are using the electrical circuit like this. Clear, girls? Any doubt about this particular point? I hope not, right, girls?
No, miss.
Very good. So let's proceed to the next point, that is for damp condition. If you remember, in static electricity also we discussed this particular point. Damp condition is actually dangerous because we already learned water is a good conductor of electricity, whether it is static electricity or current electricity, in both the cases. And current electricity, as we are using with a very high voltage of 220 volts, it becomes even dangerous to us if we are damp, means our hand or the place where using the switch and all, that is also damp. We know water is a good conductor of electricity. So water in socket means the place where we put the plug, and plug leads to a risk of electrocution, because it's very risky. Then you will get electrified, and the person who is holding it might get a severe electric shock. If an act, okay, after that, now think about there's an electric shock to a person. So what we should do? As a human being, we have to have certain things to do. as we wrote it here, if an accident happens and someone had an electric shock, we must switch off the socket and pull off the plug before giving in help. Means we should not touch the particular person immediately before switching off the circuit or before switching off the plug and then no, before switching off the socket and then take the plug off. After that, we can immediately rush him to the nearest hospital because that is really needed. Otherwise, that particular person might even die. So we need to be very careful whenever there is an electric shock. If you don't know the switch, we can immediately, because you know, each and every flat do have a main circuit in the front beside the door, the front entrance door. There is a main circuit. There is also a plug. If I switch it off, that will cut off the whole electricity in the full building, or full flat, or the particular apartment. Then we can give some, offer some help to the particular person who is already in shock. Okay, guys? Now, tell me, do you have any doubt in this particular full topic that I have discussed with you girls? Anyone?
No, Miss.
Very good. Okay, I can see today my presence is more than yesterday. Today I got 25 girls. Good. I will take the attendance a 2 minutes later because I need to know who's not there. I am supposed to have 32 students in my class. But some of them I can see that today also I didn't see Shahad, then I can't see who else, that is Luzain, I can't see. Some of the girls I am not getting here. Okay, fine. We'll check it afterwards. Okay, guys. Now, yes, dear, anything? Any question?
No.
Okay. Now, next point is fuse. All of you go to that particular point and check. I have given two diagrams. First, the diagram that I gave you, that is the symbol of a fuse. Now, does it remind of you of any other symbol that we had earlier? Does it look like any other symbols that we used earlier, girls?
Resistor, right?
Yes, a permanent resistor. But permanent resistor, we don't make the wire go across. Here we are showing the wire go across. Because actually fuse is nothing but a small piece of wire. Okay, and that particular wire is going to have a very high resistance which will protect our appliances from getting damaged. And how? We'll discuss it. And after that, there is a small diagram I gave you. This diagram will get in paper 2 almost every time. This question will be there that among the following, which one is giving us the correct placing of a fuse. So we have to remember this one. This diagram is for paper 2. Now let's come to the topic, fuse. What is a fuse actually? A fuse is a device that protects a circuit. It melts and opens the circuit when high current flows. Now you guys tell me, yesterday we have discussed open circuit, closed circuit. Just tell me girls, in open circuit, does the electricity flow? When it is open circuit, will it be flowing?
No, only in closed circuit.
Exactly. That's really good. That is why we are saying that whenever we place a fuse, if the electricity comes in a higher value, it will actually melt this wire and then the circuit will become open. So that the electricity cannot reach your appliances, whether it is a small lamp, whether it is your laptop, or whether it is your AC, whatever the appliances it is connected with, it will protect the appliance from getting damaged because the circuit is being cut off. Now, what is this fuse and how does it look like? You might have seen, even in Bangladesh and even here also, we always say if there's any trip, electricity trip in any room or any part of the apartment, we say that okay, the fuse is gone, so we need to replace it. What we do, we just take the fuse from the board and there's a small wire. We see the wire is being cut off there. We have to just replace another particular wire or we can just buy another fuse and put it there. Then the electricity will be again in our flat. So what is that? It consists of a thin wire. See, I wrote the word thin. It's very important. Okay, now I want, who's there? Mukarrama, are you there? Hello, Mukarrama. I want to ask you a question. Mukarrama, are you following my class? Could you tell me a thin wire? What could be the possible resistance, Mukarrama, or a thin wire? What do you expect the resistance of a thin wire to be? Is it more, less, what?
Resistance of a thin wire. It will be l-
Very
less.
No, dear, it will be very, very high because we learned that
Uh,
cross-sectional area is inversely proportional to the resistance. So if the cross-sectional area is small, means it's a thin wire,
yeah, yeah.
yeah, resistance will be very high. That is why we are using a thin wire as a fuse. So that whenever electricity is coming towards your appliances, it will get a huge amount of protection from this wire, and the wire will get really hot and it will get melted and cut off the circuit. That is how we are going to use the fuse to keep our appliances safe. So we wrote, a fuse protects an electrical device against the possibility of overheating and setting fire to the house. There can be an accident which can even leave the whole building or the whole house on fire. So we need to have a fuse. Before it was like that each flat used to have, or each apartment used to have a single fuse. Now what they do, each and every appliance, they put a built-in fuse so that if due to any reason the main supply fuse is not functioning, the other one which is built in, they put a fuse there so that it can actually keep your particular appliances from getting damaged. Now it is because there is every chance, anytime it can happen, right? Yes. So we have to do it like this. Now let's go for the diagram. The connection of the fuse in the main circuit is as follows. Now if you just look at the diagram, girls, I wrote two holes I gave you over there. One represents the live wire, another one neutral wire. And I already mentioned to you that live wire should always go to a fuse, then to the switch to the lamp. I just gave you the example of a lamp. It can be anything else, any other electrical appliances it can be, then to the neutral wire. This is the simplest circuit arrangement with the live wire of a 2-pin plug. Okay, guys? This is how we have to do, because we cannot place the live wire, you cannot place the fuse on the neutral wire or after the lamp or after your device. It has to be before your device and close to the live wire, because from the live wire the electricity will come, it will go through the fuse, then it will go to the particular appliances. In the middle, we can just put the switch. If you switch it on, circuit is closed and the electricity will start passing. But if it is by any chance it is coming out with a higher value, definitely that time the fuse will melt and keep our appliances safe. Right, guys? Fine. Now I want to go to fuse rating. This is another point you will get in paper 2. Nowadays in paper 4, a question are covered. There are so many questions are there. In 2019 also, October, November, one question came from this fuse rating in paper 4. Hopefully, I'll be doing all those questions with you, and you'll see that how we just match this point that we learned here and to the question. Okay. Now, how will you decide that what type of fuse you will use in which particular device? Because we have to have a calculation. With it, we can understand that what type of fuse you should use. You cannot just buy one fuse and use it. Okay. Now, in this note, girls, all of you keep your pen with you. In this note, I'll make some small changes. So I want you to keep a pen or a pencil or a small paper where you can write. Later you will correct your record book. A small change I want to make there. I'll give you. First, let us start. What is this fuse rating? The maximum current a fuse can carry without melting is fuse rating. As I told you that each and every fuse has its own value. If it is written 3 ampere, means highest 3 ampere electricity can pass through it. Afterwards, if it is more than that, it will get overheated and melted, and it will get damaged completely and protect your appliances. So how will you decide whether you will buy a 3 ampere, 1 ampere or 13 ampere? How will you decide? For that, we need to go for this particular calculation that I gave you. The fuse rating must be higher than the current that normally flows through a device, but as close as possible to this value. Means we'll find out what amount of current is needed for a particular device. And we are going to choose our fuse which is very close to it. But it has to be a little bit higher, but close to it. We cannot just use very low, then the device will not function. And you cannot use a very high value, then your device will get damaged anytime. That time it will be of no use of the fuse for keeping it safe. So what could be the possible calculation? I did it over here. Do you remember this equation, girls? P equals to VI, we discussed. Power equals to voltage multiplied by I, electrical energy change that we discussed that day, electrical power, all those equations. From there, I'm picking this equation one more time. So P equals to VI and I equals to P by V. Now you remember this P by V means the power of your particular device. If you buy any electrical appliances, on the top it will be written what is the power and what is the voltage it need to do. As we are using it at home, we'll consider, think about, I have a blender which is having a power of 600 watts. I gave you the example with that. 600 watt is the power of the particular blender, and it is going to function with 220 volts. That is the main electricity that we find. As well as, did you notice that I have multiplied by 125%? Girls, did you notice in the calculation I wrote it 125%? And the next step I wrote 1.25. Did you understand why I did it like this? First of all, I will tell you. First of all, 125% is an international value. They have decided that it has to be multiplied by 125%. Point number 2 is that 125% is actually what? 125 divided by 100, isn't it? So it comes out as 1.25. Correct, girls? Mathematically? Fine. So whatever the current will find out, we have to multiply by 1.25. Then what I said, think about, I have a blender which is having, this blender is having a power of 600 watt, and I have to divide by 220 volts, that is my line voltage, multiplied by 1.25, and I got the answer 3.4 ampere. Okay, if it is like that, so we are saying that it can be higher and a bit closer. So I can go for 3 ampere fuse is suitable for the appliances rated up to 600 watt usually. Okay, now let me tell you that why 300? Can I go a little bit higher? I actually cannot go more than this. Why? I'll tell you afterwards. So for this particular appliance, you'll remember 3 ampere fuse will be the suitable one. Now just check next part. I wrote it before something. I want to make a change over this. So the first sentence will be changed. Could you please write down the new sentence that it will be replacing? You will be writing the first sentence like this. All of you please write, and later you'll fix your record book. It will be like this. There are few fuses of current ratings. Because you cannot just go to the shop and say, give me 2 ampere, give me 5 ampere, 4 ampere. We cannot select that. There are certain values and you have to buy among them only. You cannot buy anything else. So what are those values? Yes, dear?
Can you repeat?
Yes, I will repeat it right now. There are few fuses of current ratings. There are few fuses of current ratings. Then 1 ampere means 1A, comma, 1A, comma, 3 ampere, comma, 5 ampere, comma, 13 ampere, 1, 3, 13 ampere and 30 ampere available. These are the ones you will get on the shop. 1 ampere, 3 ampere, 5 ampere, 13 ampere and 30 ampere available. So how many we got? Yes, yes, sure. There are few fuses of current ratings. 1 ampere, 3 ampere, 5 ampere, 30 ampere and 30 ampere available. Full stop. Only this sentence you have to make it, and the rest are all the same. Could you make the change, girls?
Miss, can you repeat it?
Miss, can you repeat it?
Yes, yes.
Miss, we already wrote a sentence where it says there are only 3 fuse ratings.
Yes, 3. But I want you to make a small change there. It's not 3, actually, we have 5 here.
Okay.
That is why I am making the change. I'll repeat the sentence. Could you please make the changes? There are few fuses of current ratings. Few, I said. Few fuses of current ratings. 1 ampere, 3 ampere, 5 ampere, 13 ampere and 30 ampere available. 30.
Miss, is
Yes,
it
please.
few or 5?
Few. Write down few, no problem. Altogether it becomes 5 actually, no problem. Just few. Okay. Now girls, just look. The previous example that I have given, there I got the current 3.4 ampere. Now just look, I have the option 3 ampere and 5 ampere. So if I use 5 ampere, do you think it can protect my appliances?
No.
That is why I stick to 3 ampere. But if it was 4.9 or 4.5, then also I have to go to 5 ampere. I hope you understand the calculation because we'll be doing paper 4 questions regarding this topic. Clear?
Yes, ma'am.
Very good. Now I will continue on that part. After that I wrote, after calculating the current needed for the device, choose the fuse to protect it from getting damaged. As I said, we'll do the calculation and after that we'll go for the particular choice of this one. Among these, if it is coming out, think about 28, it came out. 28 ampere for my needed for my appliance. Definitely I have to go to 30 ampere switch or 30 ampere fuse. Isn't it, girl? We'll decide which switch or which fuse we are going to use after calculating the current for your particular device. Okay? Now, okay guys, in 1 minute, less than a minute I have, I'll just give you another link and then we'll connect with you. Okay? Now, you just tell me girls, do you have any doubt in this fuse breaking? You just remember this value 125%, 1.25. You have to multiply the reading, the calculation of I with 1.25. It's an international value they have decided. Of course, it has a welcome back, girls. Okay, today I can see Varda is present. Varda, what happened in my previous class? You were not there. Are you okay, Varda? Varda, could you hear me? Hello? Varda, are you there? Okay, fine. Because I didn't find you in my previous class, so I was thinking, are you all right or not? It's good to hear that you're fine. Okay, let's proceed. We have finished our that fuse rating. Let's go to our next topic that is called circuit breaker. You'll remember the function of this fuse, circuit breaker, all are same. Just to keep our appliances safe from getting damaged by over electricity passing through it. So what is that? It is actually, we're going to learn a little bit more about it in our next chapter, that is electromagnetism. There we'll learn a little bit more about the idea, about the construction, about the function of this one. But right now we'll just say, if there's a question that how to protect your appliances from getting damaged. So we can have two options, right? We can use a fuse there with a particular rating, or we can use a circuit breaker. And what is the circuit breaker? A circuit breaker is an automatic switch which turns off when the current rises above the specified value. Here you don't need to make any change, but in case of a fuse, you have to change the fuse. Here there's a switch, it will just turn down, means it will switch off. All you have to do is after going to that particular point, you just switch it on again and you have restored electricity in your flat one more time. So it's kind of more efficient than the fuse also. But every appliances do have a built-in fuse inside it. So let us see what we wrote after this. They contain an electromagnet which, when the current exceeds the rated value of the circuit breaker, becomes strong enough to separate a pair of contacts and break the circuit. This method you learned in the other chapter, as I told you, in electromagnetism. But right now you remember the purpose of having a circuit breaker is that whenever there is a particular value of electricity coming towards your flat or the apartment, immediately it will switch it off so that there should not be any other passing of electricity and you can have your appliances from that not getting damaged. Okay, guys? Now, next point, this is also a question for paper 4, that why you have to earth the metal cases. Means some of the appliances we do use, they do contain a metal container or a metal casing. So whenever it is a metal casing, we do have a risk, a lot of risk there because metals are very good conductor of electricity. So by any chance, any of the wires, especially the live wire, comes loose. Okay, I'll give you the example of an electric kettle. You know that the electric kettle do have a part where it will be the metal body. From the metal body, there will be a plug-in system. From there, it will go to the socket, another plug. So by any chance, wherever it is connected in the metal body of the particular appliances, if there's a loose connection on the live wire, there's every chance that the whole electric kettle will become electrified. So that time anyone touches the metal kettle, they will be getting electrified. So to prevent that, what we can do, we wrote it, if the live wire of the mains plug comes loose and touches the metal body of the device, current passes to the arc wire and prevents the chance of an electric shock. So when the arc wire is there to protect us from getting electrocuted by the appliance, so that time the arc wire is very much needed for us. It is a safety wire to protect us from getting electrified. Okay. Now, after that, I want to go for the last topic of this, not last topic, it's another important topic for us, that is short circuiting. Means it is in fact, in this particular topics, it is the last one. Now, this word short circuit, you might have heard many times, because whenever there's a fire or any accident, electrical accident happens, people say, okay, there was a short circuit, that's why the whole building caught fire. But what is this short circuit thing? We need to understand it very carefully. Like the general people say short circuiting, it is not like that. It has an in-depth meaning. We need to understand there will be some problem in the circuit system. When they made the circuit, there was some loose connection or something was there. And what is there? We need to know from here. Okay. Now look, joining the ends of an electrical device by a conducting wire is called the short circuit. Means you know that from an electrical device, two wires should come up and both of them should go to the live wire and the neutral wire. But if you put them together by any chance, when you're connecting them to the mains electricity, if both of them comes together, that is called short circuit. And then what can happen? When short circuited, current will not flow through the device because electrons always takes the easiest path. Now, all of you look at the diagram that I gave you. That will make you understand the circuit very easily. Now, I want you to concentrate. On the first diagram, I showed lamp L1 and L2 shows equal brightness. Now, I want to ask you a question first. If you just look at the first diagram of the circuit that I have given to you, here I showed you just a normal cell, not the 220 volt. From there, we have connected L1 and L2. Could you tell me what type of connection I have given to this L1 and L2 lamp? Series connection. Yes, very good answer. It's a series connection. That is why I wrote something there, equal brightness. Why? Because it is a voltage division circuit. And both of them are identical lamp. They're going to get the same voltage and they'll show equal brightness. Okay. Now just look at the other side, another diagram I have given. The same circuit, but I placed two wires there. If you just look at it, one wire I placed across L2, another wire I placed across the source. Okay, and if you just look at the diagram, below the diagram I wrote, L1 is getting brighter than before. And L2 short circuited and will not even shine. Even if it shines, it will become really, really dim. Most of the time, it doesn't shine. Why? First of all, if you just look at the diagram, we know the conventional current comes from positive terminal and it will go to the negative terminal. Okay, so from the positive terminal, the electricity came on, the current came on, went through the L1 nicely. After coming to a point where it can either go to L2 circuit, L2 lamp, or it can go to the simple wire that is across. Here it has two paths, means it is a parallel circuit here. L2 and a simple electrical wire that is given connection to it. Right, good. So we can expect one thing, that the lamp is having more resistance than the simple wire. And electricity always loves to go to the easy path, means where it will not come across a huge amount of resistance or huge amount of protection. Just like us, we don't want to go to a bumpy road, we want to go with a smooth road, isn't it, girls? So the same thing is going to happen here. The electricity after crossing L1 will choose the easy path, means through the wire, and it will go back to the negative terminal. So what is happening here? L2 is getting deprived of electricity. It will not even get any electricity to pass through it. That is why we wrote L2 is short circuited. There is an easy path for it. So it is getting short circuited and it will not even shine. So this part we don't have any problem. No accident can occur over there because two lamps, one is shining, another one is not shining. Now girls, I want someone to give me the answer. Why did I write here that L1 is brighter than before? Who can give me this answer? If you understand the circuit, then you can give me the answer. Tell me. Did you get it? Why L1 will be brighter than before? I wrote the word clearly, before. Whatever brightness was there, now it is more. Why it became more?
Is it because the voltage changed?
Yes, so what do you expect? The voltage could increase or decrease?
It
The
got
voltage, correct answer. Very good, Apna. It actually got increased.
increased.
Yes. Actually, what happened over here? The resistance of L1 remained the same. But the problem is that now L2 is not getting any electricity. But the wire which replaced it, that has a lower resistance. So definitely L1 is having more resistance in comparison to the other. Isn't it, girls? Okay, fine. So as L1 got brighter than before and L2 did not even shine, so our circuit is smooth. After that, just look, one thing I did on the top, that is, there is a simple wire that I connected across the source itself. And I showed the, if you look at the arrow, after coming to that point, it didn't go to the negative terminal, because if it goes to the negative terminal, it will come across certain amount of resistance, because a source, a cell, or a battery itself has its own resistance, the one we call its internal resistance. So definitely the electricity will not love to go to that. It will love to go to the easy way, that is the simple wire that is connected across it. So when it goes, it comes straight on the top of the positive terminal. So can I say now negative and positive came all together? So it is a short circuit. And that short circuit is highly dangerous. That can cause fire to a whole building. If it happens with 220 volt, definitely it will be really, really dangerous. So that thing sometimes accidentally it happens. Nobody will purposely do it. Accidentally, if a loose wire is there, if that touches from the live wire to the neutral wire, then there can be a huge accident like this. As I told you, that can even catch fire for a whole building, and the whole building can also get damaged. So that type of accident does happen. Sometimes we see that one fine morning, a full building is having fire. Due to what? Later we come to know there is a faulty connection, or there was some accident that happened due to the short circuit. So is it clear, guys, now what is a short circuit and how does it actually work there? Hello, guys. Is it
Yes,
clear?
miss.
Very good.
Yes, miss.
Okay. Now I want to check with you guys. Yes, dear. Any question?
I have a question about fuse.
Sure. Say.
What is the difference between fuse and resistor?
Okay. First of all, resistors can have different values, and resistor is used in a circuit to protect your appliances from getting extra electricity or more electricity. And fuse is something which will be having a particular value. As I said, fuse can have particular ratings and particular value, a particular fixed amount which cannot be changed, and it will be given just to protect your appliance. No other function is there. But a resistor can have some other function also. But basically, a fuse is nothing but a resistor, because we are using a small piece of wire inside. That wire provides some resistance to protect extra electricity to come to you, to reach your appliance. Basically, they are saying.
Okay.
Okay, fine. Now,
Okay.
let's come to the, you're welcome here. Let's come to the last topic of our current electricity, that is two-way switch. This one also came in one of the exam paper you'll be solving with me. There we discussed what is this actually and how do we apply it. Okay, now just imagine that you are living in a 20-floor building and you are living on the 19th floor. And you got the duty to switch off the lights, which is at the ground floor, as well as you are living on the 19th floor. So that time, definitely you don't need to come down every single night and switch off the light that is on the ground floor. We can have a switch which can be operated in both the places. That is the one we are showing here. Two-way switch means you'll be staying in one of the place and you can operate the switch. It can be on, off, like that. So what we did, what I did here, in most houses, landing light can be operated from upstairs. And what is this landing key? That is the part when you enter a building, a huge building or whatever, when you enter a building, there's a place from where the stair starts. And it goes to the first floor, that is the first floor landing. If you go to the second floor landing. Those are the landing thing we call. So just imagine that you have a landing light which is at the ground floor and you're living in a higher stairs, and you have to operate this switch. That time we use this arrangement. If you just look at the diagram, I gave you here the 220 volt, that is the AC symbol, and there is a lamp, and that lamp is having two switches. One is X and one is Y. And X has, if it is at 1 and 2, you can see two plugs on there, I showed you. If it is 1, then you can see it is on, and if it is at 2, you can see it is off. At the same time, on the other way, it is like that. But this switch will be, or this lamp will be functioning by the function of the two switch. So either switch is open. First, if you just look at the diagram, if you operate one of the switch, then let it be like this, and you go for the other switch. Think about in the ground floor, the switch that is there, you just keep it in one position, and you go up in your own flat. From there, you just operate. Think about for due to some reason, now you are in the ground floor. From there, also, if you want, you can operate this switch. So how we did it? I gave you a table. There I wrote position of the switch X, position of the switch Y, state of the lamp, means whether it is on or off. If you just look at the diagram, you can easily understand. You have to complete the path. Now, if you just look at it, the way I gave you the diagram, the switch X is at one position, Y is also at one position. So you can understand the circuit is getting completed. Look at the path. It went from X to 1, 1, and it goes nicely. And after that, it came to Y and completed the circuit. So we can say, what is the status of the lamp? It is on. Right, guys? Then again, if you just look at it, now I am saying that the position of the switch will be at 1. Let it be. And the position of the switch Y went to 2. So if you just rub that part and put it at 2, you can see there's a gap in between the whole circuit. Means it is not completed. So definitely the lamp will not be shining. It's off now. At the same time, when you are placing it on 2, means X is at 2 and Y is at 1, then it is off. When it is at 2, Y is also at 2, then it is on. You have to follow the circuit. Did it complete or not complete? If it is completed, the lamp will be on. If it is not completed, the lamp will be off. Simple as that. Okay, guys. But why do we need it? See, we wrote it at the end. If both switches are up or down, you know, the home switches that we are having, it can go up and down like that. The circuit is complete and the lamp is on. But if one switch is up and the other one is down, the circuit is open, so the lamp is off. It is actually a method of operating a switch, in operating a lamp, in having two switches in two different places. Okay, it's up to you where you want to, from where you want to operate it. But you have to make sure that both should be at the same status. Means both should be at the on position, then the lamp will be on. If both of them are in the other side, means up or down, if you consider like that, then both will be off. The lamp will be off. If both of them are, one is at on position, another one is at the off position. Up, down. If both up, then the lamp is on. Both down, lamp is on. Okay, guys? So I think I am almost done with this particular chapter. After that, girls, I have given you a paper which is having some electrical symbols. Okay, some of them already I have used with you. Some of them I didn't use till now. But you are going to draw all of them because next chapter we have electromagnetism. There we'll be using some of them. And later in grade 10 we have another chapter that is called electronics. There we are going to use the rest of them. But I want all the symbols to be together. Okay, that is why I have given you all of them in one place. So that if the paper is in front of you, you can check with all the symbols and TV in front of your eye. Now, girls, as I have around 5 to 6 minutes in my hand, before going to the past paper, hopefully next week I'm going to start the past paper with you regarding this particular chapter. And as I told you that almost every year, every question paper, all the variants we do have one more question regarding this topic. And they are different. Some of them are having a circuit. You have to explain the circuit, do the calculation. And some of them are like that. They are having some theoretical questions. Along with that, some calculations. You get lots of questions, lots of variety of questions in those question papers. Okay. And as I told you that for grade 9, we actually don't have any boundary. So hopefully next week I will be asking you, as you have two parts of physics, right, girls? Past paper 4. So I want to start with the second part. Could you just tell me what are the years you have in the second part, girls? One of you tell me, please. In the second part of physics, which year questions do you have? Afifa, could you tell me please? In the second part of physics, paper 4, these are the questions we have here. Hello, Afifa, are you there? Yes, which years you have there? Could you tell me?
From 12.
2012. Okay, 2012.
No, Miss, wait. I think it's from
Yes, miss,
yeah,
from 12.
from 2012 to 16 or 17.
Okay, fine. Very good. So I will do one thing. I want you to get ready in my next class. As you know the timetable, next Wednesday, Thursday, inshallah, I'm going to have another class with you. 2 more classes with you. So that class, I want to start from 2012. The second part, I want to do first. But I want you to do one more thing. As we have the weekend, read the note thoroughly. Any doubt you can ask me in the next class, and while doing the past paper, you will understand how we are molding our notes and how we are using our idea and the knowledge of this current electricity to solve the past paper. Okay, so next day, you have to be ready with your past paper, with a pencil and supporting papers, calculator, all in front of you. I know it's kind of difficult, but we have to carry on like this right here. Because when the school reopens, we'll be having our final term. And actually, I was supposed to have this current electricity assessment with you last week, I remember. The way I planned, it was supposed to be last week, but I couldn't do it. So at least we can get ready for the final exam. And as I told you before, girls, I already marked your the other assessment of the static electricity, and I have the mark with me, but I don't want to give it to you all together like this. So, inshallah, one day I'll be giving it to you. But most of you got very good marks there. Few of you couldn't score good marks, but the others mostly got very good marks. Okay, so that is why I'm asking you that you have to be ready with your past paper in front of you. You'll be doing along with me. When you get stuck, keep on asking me question. I'll be solving it. Together we'll do it. Okay, you'll be doing the calculation, and if you want, you can also try at home within the weekend and check it. If you can do it, that will be really good for us. Together we'll solve. As I told you, 2012 to 2017 or 18, whatever you have in that book, that part of your paper 4, we'll do it first, and then we'll proceed to the other. Then we will go back to the part. Okay, so make sure you are having the past paper with you. And please make sure that you are learning the current electricity, the chapter thoroughly. Because no matter whenever the school is going to reopen, we'll be having final chapters. So we need to be ready for that. Right, girls? Okay, now tell me any doubt you have? Because 1 minute I have before concluding my class.
Miss,
Sure.
can you explain the two-way switch again?
Which one here?
The last one that we just did
Okay,
now.
two-way key, right? That one.
Yes.
Okay. For that, I want you to concentrate on the diagram and the table. Then it will be very clear for you. Look at the diagram. Did you notice that it is two-way switch? The diagram, if you just look at it, you can see clearly the path is completed, isn't it? So it's a complete circuit. In the second table, the table that I gave you, check x remains the same and y goes to 2. So roughly you just draw at 2 and see what happens. It becomes open circuit. The circuit is not completed. So the lamp cannot shine. That is the reason behind it, nothing else. So you make the rough. Did you understand now?
Yes, Miss.
Very good. Okay, fine. So Alhamdulillah, I'm done with my class. Inshallah, next week, Wednesday, Thursday, I'm going to have again the class with you. In between, if you have any doubt, you can message me also. No problem about that. Okay, guys? Okay, let me conclude my class now. Stay home, stay safe, and stay for all of us. Okay, guys?
Okay, Miss. Assalamu alaikum, Miss.
Wa alaikum salam and Allah Hafiz.
Bye, everyone.
Bye.
See you next week again on Zoom. Allah Hafiz, guys.
Assalamu alaikum, Miss.
Wa alaikum salam.